All right, for today's video, I want us to look at Charles' law and Gay-Lussac's law. Now, for these two laws, you need to have the temperature in Kelvin. Kelvin is equal to 273 plus degrees Celsius. Now, the reason for that, Charles was working with gases, and he found that for every degree temperature change, the volume changed by 1 divided by 273. So that's where the Kelvin scale comes from. And he theorized then that at negative 273, there should be no molecular motion, there should be no interaction. And that's not entirely true. A real gas and an ideal gas are not the same. Real gases do have attractive forces that exist. But for the most part, at room temperature, ideal gases and real gases are one and the same. So the first one then is Charles' law, and that is volume over temperature. And I'm just going to be consistent. This is hard for me. I'm used to being the prime, but we'll say equals V2 over T2. And again, this is Charles' law. An example of that, I'm just using the first problem on your worksheet. It says an unknown gas has a volume of 120 milliliters at 313 K. What is the volume at 283 K? And so what I did was solve for volume for V2. V2 equals V1. That's a 2 up there, I'm sorry about that. Times T2 divided by T1. And you plug your numbers in, and the original volume was given to you at 120 milliliters. The new temperature is 283 Kelvin, and the initial temperature is 313 Kelvin. Kelvin cancels out, and then we're left with the answer of 110 milliliters. And so that's how you use Charles' law. Again, Charles' law essentially states that as you increase the temperature, if you hold the pressure the same, the volume must also increase. As you decrease temperature, then the volume will decrease. And that really goes to work with our kinetic molecular theory, because if you remember, our kinetic molecular theory states that molecules move faster as you increase the temperature. Okay, the second law then, and I'll switch sides over here like I've been trying to do, is Gay-Lussac's law. And Gay-Lussac's law then looks at the relationship between pressure and temperature. So you can say then that pressure 1 over T1 equals pressure 2 over T2. And the first problem of the worksheet says solve for the missing value, and it gives you the value in kilopascals. And again, the pressure is not important as long as the units are consistent. And so we have this formula, and what we're asked to find is T2. We're solving here, and I know this is mathematically a little more challenging, but I know you guys can do it. Just do your cross multiplying. So you have T2 equals P2 times T1 divided by P1. And then you plug your numbers in. The next pressure, the second pressure, is 216 kilopascals. The initial temperature is 323 Kelvin, and the initial pressure is 97.6 kilopascals. Units cancel, and you're left with an answer of 715 Kelvin. Now, this didn't ask us to do that. If it asked for degrees Celsius, then you would have to subtract 273 from this, and then you would get 442 degrees Celsius. Now, notice when you're looking with Celsius, it is degrees Celsius. In Kelvin, there's no degree sign. It's called the absolute temperature scale, And with that in mind, that's why we don't have a degree with it. And so again, Charles' law and Gay-Lussac's law. Earlier we had Boyle's law and some pressure conversions. So I hope this helps get the worksheet started. Work on it if you get a chance over the next few days, and then send me questions. We'll hopefully get those answered for you. Hope you're having as good experience as you can, and try to enjoy the weekend as best you're able. Have a good day.